All right, welcome everybody. So we're going to skip 1, 2 and go straight to 1, 3 in the book. And it's I think it's a little bit easier of a section. So that's the good news. So 1, 3 is going to be about complex numbers. And complex numbers have an I in them. So this is technically what I stands for. I is the square root of -1. So before you learned I, your teacher might say, oh, you're not allowed to square root negatives. Okay. But as we learn more, we find out we can do some math with the square root of a negative if we include this I. Now, more commonly used than what I is, like honestly, you could leave my class and not know what I is. More commonly used is I squared. So definitely make sure that you know that I squared is -1. You'll probably just naturally memorize it throughout the lesson today. So whenever we see a square root inside a negative, the very first thing we're going to do is pull out an I and change it into a positive. Okay, so that'll have to be step 1 before you do any math on it. Just pull out the I and make it positive. All right, so here we go. Write each expression in terms of I and simplify. So we're going to do exactly what we just did, right? We're going to pull an I outside of the radical, and we are going to make that instead of a -100, +100. And then do whatever math you can. So we actually can square root 100. 10 times 10 is 100. So this will become 10I for our final answer on that. Number 2, same thing. We're going to pull out an I. Write it as the square root of 36. Well, we can square root 36. 6 times 6 is 36. Notice once you square root, the square root sign goes away. I have some students who say stuff like the square root of 16 is square root of 4. They still have the square root symbol there. And then that's wrong, so you need to keep going. Well, the square root of 4 is 2, right? So none of this makes sense. You want to just make sure that once you've square rooted the number, that the symbol goes away. The square root of 16 isn't the square root of 4. The square root of 16 is the number 4. Okay. All right. So number 3, we're going to pull out the I. So we have square root of 6. Now you'll notice that this one is not a perfect square. Nothing times itself gets you 6, right? So in that situation, you would have to check and see if that number breaks down. You can do that with your calculator. A lot of your calculators, especially if you have the Casio 300 FX, right? If you put square root 6 in there, it'll do the breaking down for you. Okay. So the 2 ways that I'll model for you in the notes, one way is to just kind of like do a prime factorization tree, like break it up until you get into all primes. If you see any doubles, then it can break down. But I don't see any doubles here. I only see 1, 2, and 1, 3. I don't see any doubles. So since there's no doubles, then that means that this number will not break down. I'll show you the second way when we get one that actually can break down, you guys. Okay, number 4. So we're going to pull out the I and we're going to make it positive root 21. And again, if you take 21, you break it into its prime factorization, it's 3 times 7. There's no doubles, which means just leave it alone. 5. We're going to go ahead and pull out the I. Now, square root of 50 will break down. If we try to do the prime factorization for 50, it's going to be 5 times 10. And again, if you saw 2 times 25 instead of 5 times 10, that's fine, you guys. It'll all come out in the wash. It doesn't matter what 2 factors you pick. Okay. And then 10 is 5 times 2. But now we have a double. So doubles go on the outside and singles go on the inside. I was observing a teacher, I can't remember who, it's been so long, and they said it takes two people to go out on a date, right? So the two people will go out and single people stay home, they stay inside. Okay. All right, help me remember. Doubles go out, singles stay in. Okay, so then what does that do to this I root 50? Well, it's going to change it to 5I root 2. So you kind of, that could be one possible answer. Or sometimes they like the I to be at the back end. Okay, but make sure it's clear that it's not under the root. I don't like to write it there because I'm kind of sloppy. So if my root gets a little long, it looks like the I is under the root. This is my preference, okay? But sometimes Connect Math makes you have the I at the end. So just make sure that it's really clear that you get out of the square root. So when you're in Connect Math, you have to hit the right arrow to get out of this root so that you can type this I, or else it's going to mark it wrong. So this would be wrong. This, you have to get out of it, is correct. All right. So number 6, it's practice. Oh, so the second way. So besides doing it that way, sometimes it's easiest to just find the perfect square inside of it. That's, if you're good at multiplying, this will be the way you love. So when I think of 50, yeah, it's 5 times 10, but I want to break it down as 25 times 2 because 25 is a perfect square. I can actually square root 25. The square root of 25 is the number 5. So you can see that it matches with the answer that we got doing it the other way, but I feel like it just gets you there a lot faster. Okay, but the key is you've got to be able to find a perfect square inside of it. On this next one, it'd be hard for some people to find the perfect square, I think. So whichever method works best for you. All right, so we're going to plot the I, so it's no longer negative 48, it's positive 48. Now, if I were doing this, breaking it down, I happen to know that 48 is 16 times 3. Let's do math all day long, right? Okay, so 16 times 3, and 16 is a perfect square, so it should be 4 root 3. I don't know that everybody would have spotted that it's 16 times 3. So let's do it the other way. Okay, so 48, again, it doesn't matter what factors you pick. Maybe 4 times 12. 4 is what, 2 times 2. 12 is, you know what? I'm just going to do it this way. 12 is 4 times 3, right? Yeah. I'm not going to go all the way to prime factorization. I mean, technically, you don't have to. If you can spot a double already, then that's going to go on the outside. And as long as what's left over is prime, then you're good to go. Okay. So let's say that I didn't know that. And I just kept going, right? 4 times 12. 4 is 2 times 2. 12 is 2 times 6, let's say. This is 2 times 2. Well, you would have a pair of 2s, and you'd have another pair of 2s. So what that would mean is on the outside, you have 2 2s on the outside. And anything that's a single, well, that's going to go on the inside. Okay, so still single people stay inside, doubles go out. Okay. And so it still gets you 4 radical 3 or 4 root 3. So what you can do, just make sure the stuff under the root is only primes, okay? But you can use this trick of if you spot a double, even if it's not prime factorized, you can still do it. So lots of ways to get it right. You guys take your pick. Okay, so back to the final answer. So we have to slide an I in that, right, you guys? So this is going to end up being 4I root 3. Or Connect Math has asked you to put it in A plus B. All right, number 7. So we have a negative sign already. We're going to pull out the I, which is going to make the 60 positive. Okay, so that negative sign that you see is just simply. All right, the square root of 16, that's 4. So this whole thing is going to be negative 4 or root, because we square root this. Now I want to show you this one. I'm going to show you something that's wrong, but it looks so right. Okay, so this is wrong. So the wrong thing to do, if I can see myself doing, is to multiply right away. and say, well, -4 times -25, that's positive 100. Right? 10. Okay. This is technically wrong. You'll remember a couple slides back, I told you the very first thing you have to do is get rid of the negatives under the root. That has to be first, otherwise you'll get the wrong answer. You can never multiply or divide when there's a negative under the root. Multiply or divide. I'll show you, but that's actually not the right answer. I mean, it looks so good though, right? Okay, so let's go in and do right, wrong or right, correct. All right, so the correct way of doing this. Pull the i's out and make the roots positive. So square root of 4 is 2, so this will become 2i. And then all right, and then the square root of 25 is 5, so this would be 5i. So when I multiply those together, 2 times 5 is 10, and I times I is I squared. Remember I told you guys, hey, if there's one thing you need to know, it's that I squared is -1. So this is really going to be 10 multiplying by -1. So the answer, it turns out, is -10. You'll notice it does not match what we got doing it the other way. Okay, so you've got to make sure that you know, hey, never do math like multiplying or dividing or anything when there's a negative under the radical. Now that we know it, we should be good on it. I'm going to pull out a knife. So we're going to go ahead. You can't square root these, you guys. 10, that's not a perfect square. 40, that's not a perfect square. So in this case, I would multiply the i's by each other. So the I times I is going to get us I squared. And then if we do 10 times 40, that should be 400, right? So then let's see, I squared we said is -1. And the square root of 400, that's actually a perfect square. You can just use your calculator, so don't stress too much. It's going to be the number 20. So our answer is going to be negative. So same thing, even when dividing, you cannot divide when you've got a negative under the root. The first thing has to be to pull that negative out. Then you can do the division. So for the top, it's going to be I root positive 98. Now you can go ahead and divide these guys. I like to do one extra step. The one extra step being, I'm going to make one big radical, write these numbers underneath it. So it's really clear that these two can divide with each other. But you can technically do it from here. Okay. All right, so 98 divided by, sorry guys, 98 divided by 2, that's 49. 49. Calculator next to me. All right, let's see here. So the square root of 49 is 7. So this. Off of that. All right, it's a pretty good sign that it's 49 because it's a perfect square. All right, so when we write complex numbers, we write them in the form a plus bi. A lot of your directions on your homework say to write your answer in a plus bi form, and they're pretty anal about that. So you'll want to make sure that you really do write it that way. Okay. So the a part, that's what we call the real part. The B part is what we call the imaginary part. So there's going to be some questions on Connect Math where it'll have like 3 plus 4i, and it'll ask you what's the real part, right? So the real part would be 3. Now where people mess up is on the imaginary part, they include too much. The imaginary part, it would just be the 4, don't put 4i, okay? Because you can see right here it says B is the imaginary part. Well, B is just the letter in front of I. So make sure you don't include I because it's totally going to mark you off, you guys. So just a little tacky thing. But hey, you could lose some time over it. All right, simplify and write the result in A plus BI form. So I have to write this in A plus BI form. So the first thing I'm going to do to it is I'm going to add a 0i to it. That's illegal because that's really me adding nothing to it. 0 is nothing, right? So I added 0 to it, so it's still the same. And now it's in, if you look at it, A plus BI form, right? A would be the -5, and B would be the 0. Okay, so that's going to be our answer in A plus BI form. And now I think you get the trick. You're going to do write this in A plus BI form. And what we would do is we have to add a 0 to the front of it, plus 79. Now it would be in A plus BI form. All right. So I think we know right now, if you see a negative under the root, pull it out right away and make it an I. Right? So we're going to make this I root 12. We'll break this down the 2 ways so we get really good at them. My preference would be to do I just perfect square inside. You don't want to do 2 times 6 because neither one of those is a perfect square, right? We really want that 4. That'd be one way to do it. The other way would be that prime factorization tree, right? So 12 is 4 times 3, which is 2 times 4. Go on the outside, also on the inside. Either way, we get the same result as we did 3. Or use your Casio 300, FS, or FX, whatever you guys have. That'll break it down for you. I plug that calculator because it's really the best. It's a really good one, you guys, that's legal for this class. I mean, there's ones that do more, but they do too much, so you're not allowed to use them. So that's a good one that does what you need for this class, and I'll allow it as an instructor. Okay. All right, so this is going to be 2i root 3 would be one way of writing it, or I think Connect Math if the directions say write in A plus BI form. You have to put the I at the end. You would have to write it like this if the directions say put it in A plus BI form, because then you can clearly see your A, you can clearly see your B, and you notice the I is at the very back. Okay, so be careful. If the directions want A plus BI form, make sure you put that I last. All right. If you're ever given a fraction, the very first thing you want to do is split it up. So the 6 is going to go over the 3. And also the 5 is going to go over. And I will always be the last thing because we know we're trying to get it. So then you just do the math. 6 divided by 3, that's 2. 5 divided by 3, I can't really do and get a nice number, so I'm going to leave it. So we are in A plus BI form. Fraction up. All right, so there's some things that we can do here. The first thing I do is let's pull that negative out of the square root, right? So if we pull the negative out of the square root, that's going to give us I, right? So then we got to break down our root 8. So root 8 sounds going to come up a bunch in this class. Best way to think of it is 4 times 2. 4 is its square root. So it will become 2 square root of 2. Using the other method, outside, all right, so we now know that it's going to be plus 2 root 2 over time. Shove the I to the back end, you guys. That's where it needs to be for A minus BI form. So now we're still not done. So Connect Math's going to mark you off if you do this. And that's because you can divide both the top and the bottom by 2. In other words, you can reduce this or simplify it, whatever language you like to use. So I'm going to divide everybody by 2. That'll get us negative 1 over 5 plus 1 root 2 over 5. And notice I didn't write the 1 on the second fraction because it's kind of redundant to have a 1 there. Okay, so there. And now we have it in A plus BI form. A would be the negative 1/5, right? And the B would be the root 2 over 5. Okay, powers of I. So I squared is negative 1. We said memorize that, right? Memorize that. So just think of I cubed as I squared times another I. Okay, so that's going to be I to the third. We know what I squared is. I squared is negative 1. So this is essentially us multiplying a negative 1 times I. Should get negative I for our answer. I to the fourth, a good way to break I to the fourth down would be to think of I to the fourth as I squared times another I squared. You know I squared is negative 1. 1 times negative 1 gets us positive 1. That's a nice result right there. We're going to use that nice result in a couple of problems in the future. And so I to the fifth, probably a good way to think of I to the fifth then would be I to the fourth times one more I. I to the fourth is just positive 1. Positive 1 times I is just. And it's cyclical. It keeps repeating every 4. Okay, so in other words, I to the first is just I, right? I to the second, 1. I cubed is negative I. I to the fourth, 1. Well, it's going to repeat. If you go now, I to the fifth, back to I, we just see that up here, right? And then if you look at I to the sixth, it's going to be negative 1. At I to the seventh, it's negative I. At I to the eighth, back to 1. And they'll just keep repeating this every 4. Okay. So basically, we're going to use that fact to solve some other problems here, okay? So let's take a look at I to the ninth. So for I to the ninth, a lot of different ways you could think of it, and you guys take your pick, you know. It's such a small number, 9, that maybe this first way would be the best way, okay? We know we want to use I to the fourths because it's 1. So if I were to break this down in terms of I to the fourths, it'd be 1 I to the fourth, another I to the fourth, because now I'm at 8, 4 plus 4 is 8. So I would just need 1 more I, and that'd be 9 I's. And each one of these I to the fourths would become a 1. So 1 times 1 times I. Now when the numbers start getting big, like if I give you I to the, 47, it's kind of annoying to be like writing a bunch of I to the fourths till you get there. So a little quicker way to get it done, you guys, take the number, the exponent, the original exponent, and just divide it by 4. Okay, so 4 goes into 9 twice. That would give you 8. You'd have 1 left over, right? You have a remainder of 1. So one way that I could write I to the 9th is I could say that it's I to the 4th 2 times, or to the second power, with one leftover I. With one leftover I. So this one right here is going to become the exponent on I to the fourth. And then this one right here, the 1, is going to be the leftover I. So the reason why you want to write it in terms of I to the fourth is because essentially you can just do this to it once you get I to the fourth. To make sure everybody believes that, I mean, because that means our answer would just be I, right? So why do we want to break things down in terms of I to the fourth? I to the fourth is just a 1. If you take 1 and you raise it to any power, right? This could be 2, this could be 3, this could be 4. It's always going to be 1, right? 1 times 1 is 1. 1 times 1 times 1 is 1, right? 1 times 1. Doesn't matter how many 1s I put in there, it's always going to be 1. Okay. And then multiplying by 1 doesn't do anything, right? 1 times 3, it stays 3. So the second that you see an I to the fourth, you guys, more of the story, any power, cross them off, and it's just going to be this one. That's going to be the plan of attack for some of these bigger numbers that we're going to have here. Okay. For example, we got I to the 34th. Let's see if we can do this very quickly. 34, and then always divide by 4. 4 goes in 8 times. 2 leftovers. Okay. So we know that the 8 is going to be the exponent on I to the fourth. 4 went in 8 times. And the remainder is going to be how many are left over. So then how nice is this? Super nice, gone, right? So this is just I squared. And what do we know I squared is? So we're saying negative. All right. I to the negative 7. So if you end up with a negative, I'm going to kind of pull a little trick. The trick is we're going to rewrite it using the fact that any multiple of 4 will always be crossed off eventually, right? Because we said I to the 4, that's 1. I to the 8, 12, that's 1, right? Okay. And even if I go in the negative direction, so what we want to do is we want to write this in terms of 4s. So I want to go 7. Think about 7, not negative 7. I'm just going to think about 7 itself. And I'm always going to go higher to the nearest multiple of 4. So in this case, 8. And I'm going to keep the negative on it, right? Okay. So I go up to the nearest multiple of 4. We'll practice this in a second so you get good. And then I think, okay, well, how many more? What number do I need in the exponent so that when I add these together, I get negative 7? And the answer would be 1. Okay, because what's negative 8 plus 1? 1 is still negative 7. So we did this kind of tricky rewrite But what this tricky rewrite allows me to do is I claim I'll just be able to cross off this. Okay, but let me kind of show one in between step to make sure that you guys believe it. So I can write that as I to the fourth to the negative second. Okay. Because right here, whenever you have a power on a power, you always multiply. So 4 times negative 2 is negative 8. So that is exactly the same as the line above it. And we just got done saying I to the fourth to any power. That's gone. Cross it off. It's a big fat 1. Okay? So it looks like the answer to this would just be I to the first, or just I. So I want to practice this negative one because this is one of the questions I get the most on the homework. Okay. So let's say that you have I to the negative 17. I want to go up to the nearest multiple of 4. So negative 18, that's not divisible by 4. 19 is not divisible by 4. 20 is divisible by 4. Okay. So I found going upwards, right, the closest multiple of 4. And then I just have to multiply by enough i's to still make it add up to negative 17. So I'm going to put a 3 here. Negative 20 plus 3 equals negative 17, right, you guys? So it's still equivalent. And we're just going to say this multiple of 4 is a goner. You guys want to cross them off at that point, I'm totally fine with it. I go this extra step just to make sure that you guys understand. We're crossing it off because it's really an I to the 4th to the negative 5th. So it's really a 1, right? We said anytime that it's a 1, you're going to be able to cross it off. Okay, so we could have crossed it off here as soon as I see it's multiple of 4. I just wanted to make sure that you guys see that it's just going to be a 1, so it doesn't matter. And if you go back to the last slide, we found out that I cubed is really just negative I. So that's going to be your answer on that one. You can always go back and look to use the 4 that we derived at the beginning, right? These 4 right here. I'm going to want to use a lot, okay, with I to the 4th being used the most. We'll do one more because I just want to make sure that you guys really get it. So let me just insert that in. I don't know, 26, I to the negative 26. So let's see, 26, that's not divisible by 4. 27, that's not divisible by 4. 28 is. Okay, so it looks like we'd have to multiply by an I to the second because that will add up to 26. And then since this is a multiple of 4, it's 4 times 7, it's gone. So the answer is I squared, and I squared is just a negative. So once you find that factor, that multiple of 4, cross it off, guys, it's a goner. All right, number 19. We're going to add or subtract. So this should feel really comfortable to those of you who had algebra in high school, because this is basically like it's X. Okay. So to get rid of the parentheses, you're just going to take the numbers that are in front of the parentheses and you're going to distribute them in. Okay. You're going to distribute them. So multiplying 1 by something doesn't change it. So the 16 minus 3i is going to stay the same. But notice the parentheses are gone now. Once you distribute, the parentheses will disappear. All right, and then we're going to distribute a positive 1 here. So again, it's not going to change anything, right? So this is just going to stay the same. And once again, the parentheses are gone. All right. So then you're going to combine like terms in kind of a weird way because we know we have to put it in a plus bi form, right? So we're going to do the real parts first. So 16 minus 3. Then we're going to do the imaginary part second. Negative 3i plus 5i. Well, negative 3 plus 5 is 2. You always want to write that I part at the back end so that this is in a plus bi. All right, over here on number 20, a little bit different because we're distributing a 1, so that one won't change. So remember, when we distribute a negative, as we learned last lesson, all the signs have to change. So this one will stay the same. But this one will have opposite signs. So instead of a -2, a positive 2. Instead of a positive 3. Okay. All right. So same deal. We're going to combine the imaginary part. So 8 plus, and then 7i minus 3i, which will get us 4i. 21, we're just going to distribute, so you guys should feel pretty good about this. Last class in high school. All right, so let's go ahead and distribute. Let's see here. A negative times a positive equals a negative. 4 times 3, so this will be 12i. A negative times a negative, 4 times 2 is 8. And we have an I times an I. Right, we got an I times another I. So this is going to become I squared. So we already know I squared is 1, right? So it looks like we got, let's see, we get negative 12i. A positive times a negative is a negative. 8 times 1 is 8. And they'll probably want you to put it in a plus bi form. So I am going to switch it around to negative 8 in the front and the minus 12i in the back, just so that it's in that form. All right, let's go ahead and distribute. This is called foiling or distributing. We call it foiling. F stands for the first. So you're really taking the first in both parentheses and you're going to multiply them. So the F's for the first. 4 times 3 is 12. Then you're going to do the O of FOIL. So O is the outer. So the outers would be these two. So 4 times 2i would be what, 8i. The I stands for the inners. So take the inside ones. So negative 5 times 3, so negative times a positive equals a negative. 5 times 3 is 15. And then the L stands for the last. So in each parentheses, take the last. So the 5i is last and the 2i is last. We're going to multiply those by each other. So a negative times a positive would be a negative. 5 times 2 is 10. I times I is. It'll always be like this, you guys, right? When you're foiling these complex numbers, that you get this form where the last one's an I squared and the middles are both I's. So what you're going to do is you're going to combine like terms. So these guys can combine with each other. They always will be able to combine. So 8 minus 15, that's going to be negative 7. And then we know I squared is a negative 1, right? So we're going to have 12 minus 7i minus 10 times negative 1. So this is going to get you 12 minus 7i. Negative times a negative is plus 10. Then we'll do the real part first. So those are the real. So that'll be 22. 12 plus 10. And we'll do the imaginary part last. So we're in A plus B. Now you're probably noticing something, and I want you to notice it so we can go a little more quickly through these problems. We had an I squared here on this positive 8, looking back at the previous example, right? But what ended up happening after a few steps is the positive 8 became a negative 8. And that's always going to happen when there's an I attached to something. Look at this example here. We had a negative 10i squared. Well, when you have an I squared, all it's going to do is change the sign to a positive 10. But we'll use that fact a lot. When we see an I squared multiplying by something, we'll just change its sign because we know that that's what multiplying by a negative is going to do. It's just going to change its sign. All right, so let's go ahead and do this one. Now remember, squaring something means you have to write it out twice. So make sure you write it out twice, and we'll do that foiling the other way. So we got 6 times 6. got 6 times negative 7i. So positive times a negative is a negative. 6 times 7 is 42. Negative 7 times 6. 7i times 6. So negative times a positive is negative. Oops, still 42. And this one, we have a negative times a negative. 7 times 7 is 49. I times I. All right. 36. Always combine the middles. Negative 42 and negative 42 make negative 84. And don't forget, we just talked about this. What is that I squared going to do to that positive 49? Well, it's going to make it a negative 49. That's going to save us some time if we can just know that I squared will change its sign. So here's what we got. We're going to go ahead and combine the real part. So 36 minus 49 is negative 13. And then we'll bring the imaginary part. Yeah. Now this next one, you're going to do this a bunch in this class. These are actually, they have a name because they get used so often. These are called complex conjugates. Anytime that you see that the numbers are the same, but that middle sign is different, just the middle sign, those are complex conjugates, okay? So we'll go ahead and FOIL it out. And why it's important, why complex conjugates are important to us is because when you get done, you will no longer have an I in your answer. The I will go away and you'll get some integer value, okay? Or maybe possibly some whole number, or positive or negative whole number value, okay? All right, so let's go ahead and FOIL it out. My claim is that all the I's are gonna go away. So let's see. So we got 2 times 2. Got 2 times 5i. 2 times 5 is 10i. Got negative 5i times 2. So negative 5 times positive 2. Negative times a positive is a negative. Negative times a positive again. 5 is 25. Don't forget I times I squared. Now you can see that because these had opposite signs, you know, 2 minus 5i, 2 plus 5i, because the signs are opposite, it created opposite signs here, right? A positive 10 and a negative 10. And why that's important that those signs are opposites is because they will always cancel each other out then. So that's going to make those middle i's go away. And then we know that I squared is going to change that minus 25 into a plus 25, and there will no longer be an I squared, right? Because I squared is just negative 1 times negative 25 is positive 25. So we end up with a nice, pretty whole number here with no imaginaries in it, okay? So that's going to be a big deal when we divide with imaginaries, which is probably coming very soon. So this just kind of talks about what I said, A plus BI and A minus BI are conjugates of each other. And there's a property, but I feel like the more stuff I memorize, the less I truly understand stuff. And I just can't memorize a lot of stuff. My brain can only hold so much. Okay. All right. So for this one, we're going to divide with complex numbers. It's weird. You know, they say divide, but we never actually divide. I remember staring at this test or staring at this on a test when I was in Algebra 2 in high school. I missed that class a lot because it was 6th period and I had sports. And I remember getting this test and just staring at this problem and being like, I don't even know how I'm supposed to divide that. You know, and now I get why I struggled. We don't really divide. So the directions, you know, are kind of misleading, I guess. So how do we divide with complex numbers? So we take the denominator and we multiply by its conjugate, its complex conjugate. So 2 plus 6i then we're going to do 2 minus 6i to both the top and the bottom. Now you have to do it to both the top and the bottom because as long as I have the same number on top of the same number, then it's really just a 1, right? Like 7 over 7 is just 1. 7 divided by 7 is 1. And so what makes this whole thing legal is that multiplying by 1 does nothing, right? So that's why this step is even allowed. It's like, how come I can just multiply by that? Doesn't it change its value? No, it doesn't change its value because all we're really doing is multiplying by 1. Next question that you might be asking is why the bottom, right? Why the conjugate of the denominator? Well, there's this rule in mathematics, you'll really see it in your trig class if you get there, that you can't have radicals in the denominator. Maybe at some point in your high school, you had like 2 over root 2 and you had to rationalize it. The teacher said you're not allowed to have a radical in the denominator. So you're going to multiply by root 2 over root 2. Sorry, my program glitches a little bit. Okay. So it's kind of like what we're doing right now, right? When we multiplied by 2 minus 6i over 2 minus 6i. The reason why we do that is because when you multiply a root 2 times a root 2, you get a root 4. And we can square root 4, right? It's a 2. So there's no longer, and these cross off, but there's no longer a radical in the denominator. So this process is called rationalizing the denominator, but this is something that maybe you've seen that once you see that there's a square root in the denominator, you know that it's not allowed and we got to go a little bit further, okay? So let's go back to our problem then. So why the denominator? Remember way back, you guys, the very first slide of this lesson, we said that I is really a square root. It's the square root of -1. So whenever you have an I in the denominator, you really have a radical in the denominator. And you know now that that's not allowed, right? Okay, so that's why we picked the denominator, because some students will do the conjugate of the numerator, and it's like, well, we don't care if there's radicals in the top. We only care if there's radicals in the bottom. All right, so let's go ahead and FOIL this out. So we got -2 times 2. 4. We got -2 times -6i. So it's positive 12i. 7i times 2. 14i. 7i times -6i. A positive times a negative is a negative. 7 times 6 is 42, and I times I is 6. So you can see what we just did on the last 2 problems really coming into play. In fact, we're going to do it twice here. Let's do it into the bottom now. Now for the bottom, we can get a little bit lazy. Okay, we can do the first 2 times 2, which is 4. And I claim we don't have to do the outer and the inner, okay? Because with conjugates, if you remember, this will give me a minus 12i, and then this will get me a plus 12i. So we have a negative 12i and a positive 12i. They're just going to cancel each other out anyways. So you can take out the oi in FOIL and just do the first and the last, as long as they're conjugates though, right? All right, so we'll just skip to the first and the last from now on. So as far as the last, positive 6i times negative 6i. A positive times a negative is negative. 6 times 6 is 36, and I times I is I squared. So if we keep working on it, we know that those middles will combine on this numerator here. So we're going to combine 12i and 14i to get 26i. And then instead of a minus 42, I squared is going to go in and change that guy to a plus 42. Same thing in the denominator. Instead of a minus 36i squared, we're going to have a positive 36. So let's go ahead and combine the real parts first. So these two each other. That's going to give us 38. 4 plus 42. You'll notice, mission accomplished. There's no longer an I in the denominator, you guys. And that's what this was all about. That's why we even did this. Okay. I'm going to divide everybody by a 2 because I can, right? So let's go ahead and divide everybody by a 2. divide everybody by 2. Let's see, 38 divided by 2. I think that's 26 divided by 2. Gotta do that, guys. If you don't reduce, mark it off on Connect Math. So I'm going to split the fraction, and the only reason why I'm doing this next step is because the directions say write in a plus bi form. So you got to make sure that I is off to the side and that it's last. Okay. So this is going to be 19 over 20. That's the A. And 13 over 20 is the B. And you've got your I back in there. All right. It's down so it fits. Here we go. All right. So, okay. So we're going to go ahead and multiply by the conjugate of the denominator. So minus 3i. So, negative 8 times 1. Negative 8 times. Since they're conjugates, I'm just going to do the first 1 times 1. And the last. Negative 3 times positive 3. All right, so we're going to combine like terms, which means these two are going to combine with each other. So we have 1, 3, 3 minus 8i, 3i minus 8i, negative 5i. And then don't forget minus 24 will become minus 9i squared will become plus 9. Go parts first. So 1 plus 24 is 25. 1 plus 9. We can divide. That's 25 divided by 5 is 5. 5 divided by 5 is 1. I'm totally not going to write it. Maybe I will write it. And then 10 divided by 5 is 2. Right? Just because we have to go all the way plus the x, right? So we have to split this guy up. So 5 goes over the 2, and 1 goes over the 2, and I goes off to the side. Hopefully that second one really sealed the deal. Now, what if there's only one term, right, on the denominator? So your conjugate is still going to be changing the sign on it. If you want, you can think of it as like a 0 plus 4i. So that way you can see that the conjugate would be 0 minus 4i. But it turns out you get it right even if you did it by positive 4i, you guys. It might be something that would be better curious. Right? All right. So if we do this, let's see here. 4 times negative 4i is negative 16i. Negative 3 times negative 4i, positive 12i squared. And then on the bottom, 4i times negative 4i, 4 times negative 4, and I times i. So we're going to go in there. All the I squareds, their signs will get changed. So instead of plus 12i squared, minus 12i squared. Instead of minus 16i squared, all right. I'm sorry, no I squareds on that. I must be getting tired here, you guys. I let it down, take 2. 65. Instead of plus 12i squared, it's just minus 12. Instead of minus 16i squared, it's just positive 16. So remember, it's only the I squareds where their signs change, and that's because I squared is a negative 1. All right. So a couple things we could do. I'm going to put the I at the back end. It has to be at the back to be be in a plus bi form. So we're just flip-flopping, you guys, these two, their positions. Okay. Then we'll split it up. Actually, 4 goes into all those, huh? You know what? I'm going to split it this time just to show you a different way. I think on this one it works better. So you can split it and divide later. You don't always have to do the dividing before. Let me show you that in case on a certain problem that works better. So we can do the dividing now, right? And the reason why on this one it would be beneficial to do it now is because 4 goes into both of these, right? But over here, 16s go into both of these. So different numbers go in this time. All right, let's see. -12 divided by 4 and 16 divided by 4. On to the second one. 16 divided by 16 is 1. 16 divided by 16 is 1. Or you already knew 16 over 16 is the number 1, right? So this is just going to be 1. Now I wouldn't write it like that. I would not write the 1, but I'm not if Connect Math is like write it in a plus bi form if it really wants the 1. From what I remember when I did the homework, it didn't. It was okay with this. Okay. All right. So a little different ending on that. Anytime you see the same number over the same number, guys, it's always a 1. All right. I think this is our last one. Okay. So on this one, we start off with a -1 as an exponent, which, man, we haven't talked about it yet this class. So I don't know since you guys have seen that since high school. So a -1 as an exponent just means move it to the bottom and make it a +1 as an exponent. So anytime you see a negative exponent, that's what you'll do. You'll move it. If it's in the bottom, you move it to the top. If it's in the top, you'll move it to the bottom. Okay. Now, for your notes, I put that in there, but really that's anything to the first power is itself. So I probably wouldn't even write the 1 as an exponent. I would probably just write it like this. All right. So this, now you can see why this is in this section, right? We have an I in the denominator, which we said is not allowed. So we'd have to multiply by the conjugate. So 2 plus root 2i, this will be 2 minus root 2i. One times anything keeps it the same, right? Doesn't change it. So I'm just going to write it down exactly the same. And since these are conjugates, we only have to do the first, fourth, and the last. So that's going to be a positive times a negative. So it's negative. Root 2 times root 2 is root 4. And I times I is I squared. Right. So we got 2 minus root 2 I on top of 4 minus the square root of 4 we can do. So let's do it. The square root of 4 is 2. So I squared is going to change that from a -2 to it's like the denominator is just going to be a. We'll split this guy up. 2 over 6. Now the first one we can reduce. The second one we can't reduce because one's in a radical, right? One's in a radical and this one isn't. So you can't do math between them. But over here, these can both be divided by 2. So we'll reduce or simplify. 2 divided by 2 is 1. 6 divided by 2 is 3. Here is what Connect Math will count. It says to write in a plus bi form. All right, you guys. So that does it for 1.3.